Here's another problem where we've been asked to verify, which means we're going to have to show our work. It's a proof, so you've got to show all of your steps. I'll start by just jotting down the coordinates for E, which is 0, 2, and D, which is 1, negative 2. So what they're asking us is to show that AC, that's this line right here, AC is parallel to DE, okay? So you can see that they're parallel. I know that you can see that they're parallel, but we have to show this. So we're going to use the slope formula. And again, I'm going to use subscripts just like I did a little bit ago in an earlier video. So we're just going to say the slope, and we're going to find the slopes. We're going to say this, we're going to look for the slope of ED, and then we're going to look for the slope of CA, segment CA. And remember that slope is the change in y over the change in x. So delta y, just write that off to the side here. Delta y over delta x. I hope you remember that. So we can say 2 minus negative 2 over 0 minus 1. I've been using points E and D. I hope you can see that. The order was consistent. I chose to use this as my first point, so this was my second point, but then that meant that I had, for my x value, I had to use this as my first point and 1 as my second point, and I consistently did that. So you can see that it becomes 4 over negative 1, which is equal to negative 4. Now, let's take a look at CA. The points for CA, the delta x, so we're going to look, we've got 5 minus negative 3. So 5 minus negative 3. And then we've got 1 minus 3. 1 minus 3. And when we do the math on this, you can see we get 8 and negative 2, which simplifies to negative 4. And now we have proved that the slopes are in fact